Good evening, Veritas Vanguard interns. Welcome to another specialized session of our internship program. Today, we are diving into the science of bones and identity, that is, forensic anthropology. To guide us through this complex field, we are privileged to host a distinguished international expert who has been a long standing pillar in the forensic fusion family. Please welcome Ms. Alaa El Sheikh joining us live from Lebanon. Ms. Alaa is a seasoned forensic scientist whose expertise is grounded in high stakes operational environments. She served with the Lebanese International Security Forces, where she gained hands on experience in the critical domains such as fingerprint analysis, evidence collection, and criminal investigations. Her work in the field has given her a practical perspective that goes far beyond textbook theory. Currently, she serves as an instructor at Aletheia Academy in Lebanon, where she continues to shape the next generation of forensic professionals. She is also a familiar face to our community, having previously delivered two highly successful webinars with Forensic Fusion on topics ranging from forensic psychology to bloodstain pattern analysis. Today, she brings that vast multidisciplinary knowledge to the subject of forensic anthropology, sharing practical insights on human identification and skeletal analysis. Ladies and gentlemen, please give a warm welcome to Ms. Alaa El Sheikh. Over to you, ma'am.
Hello, everyone. Can you hear me?
Yes, ma'am, you're audible.
Yes, ma'am.
Thank you so much, Mr. Swapnil, for this introduction and for the forensic fusion team for this amazing workshop. It's actually a pleasure for me to be part of it. So, welcome everyone to this lecture. I am Alaa El Cheikh, a forensic scientist from Lebanon, and I will be giving you this lecture today. Our topic is related to forensic anthropology. You can see my screen, right?
Yes, ma'am, it is visible.
Okay, so basically we will learn today how can bone remains speak to us and guide us in the forensic field. So our time is tight, so unfortunately I won't be able to get to know you guys, but if you can please state in the comment section below your backgrounds, like are you a student, what are you studying, what field are you in, are you a professor? Also, I'm sorry I wouldn't be able to open my camera because I kind of have a bad connection. Okay. And of course, if you have any question, please don't hesitate to ask at the end of the lecture. I would prefer that because we are so tight on our time. Also, I will be providing you with my email at the end in case you have any question as well. So basically, we have forensic sciences students. Okay. Nice to meet you guys. That's actually great. We have a law student as well. Okay. Okay. Nice to meet you all, guys. Now I'm gonna start with the presentation and I will be checking the comment section as well. So I just want to ask you guys, what do you think bones can actually tell us? If you can open the mic and talk, because I don't really have a lot of access to the comment section while I'm presenting.
Ma'am, time since death, age estimation, and
Okay,
sex determination,
okay,
uh, stature also.
that's right. Can I know your name, please? I'm sorry, I didn't catch your name.
J.
Okay, that's right. So basically, we can know the sex, the age, the height, the health, the lifestyle, and the ancestry as well. So in today's session, we're gonna talk about what is forensic anthropology, the human skeleton and the bones. We're gonna talk about some basics. We're gonna know how to determine the sex of the individual from skeletal remains, how to determine the age, the stature, the ancestry, and I will be giving you some FYI information as well. So start off with what is forensic anthropology? Forensic anthropology is a branch of physical anthropology that applies the study of the human skeleton in order to help us solve legal and criminal cases. So, in simple terms, it's the science of studying bones in order to identify who a person was and what happened to them. Okay, so forensic anthropologists, they are basically specialists who analyze the skeletal remains when bodies are burned, decomposed, buried, or incomplete. So when normal identification methods like, for example, fingerprints or facial recognition, they are impossible, they can tell if this bone belongs to a human or not, if it's a male or a female, how old was the person when they died, how tall were they, are there any sign of injury, disease, or violence? Okay, so basically you can think of it as like, for example, the forensic anthropologist is like a bone detective. If the only evidence left in a skeleton is the skeleton, sorry, they are the person who can still tell the story of that life. Okay, so when do we need a forensic anthropologist? Basically, we need forensic anthropologists whenever the remains are found that are hard to identify by normal means. For example, criminal cases like um, murder victims buried or hidden for a long time. We have mass disasters like airplane crashes, explosions, fires, in war zones and genocides. When we find mass graves and need to identify victims, for missing persons as well. For example, skeletal remains are discovered after years. And of course, the natural disasters like tsunamis, earthquakes, and all of this stuff. Basically, whenever the soft tissues are destroyed. So, for example, if let's say a hiker, okay, finds bones in a mountain, okay, they're gonna think first: are they animal or human? Are they ancient or they are very recent? So that's when the police basically call for a forensic anthropologist to investigate. So they often go to the scene of discovery, recover the bones carefully, document them, and later analyze them in the lab to build the biological profile. And by a biological profile, I mean to know the sex, the ancestry, the age, and everything. Okay? Before we deep dive more into the our presentation, I would like to just give you an overview of the human skeleton, just to be familiar with some terms, and as a reminder. So our skeleton is the body framework, okay? It gives shape, support, and protection, and it allows us to move. So an adult has around 206 bones, and it's divided into axial skeletons like skull, ribs, and spine, which basically form the body's central core. And we have the appendicular skeleton, the arms, the legs, and the pelvis, which are responsible for the movement. Now, what are the functions of the bones? Well, they help support. They are the framework of the body. They help in the movement, like muscles pull on bones to move. They help in the protection. Skull protects the brain, ribs protect the heart and the lungs, and also in blood production, like in the bone marrow, we make they make the blood cells, and also for mineral storage, especially for calcium and phosphorus. Now, let's talk about the bone structure. Bones mainly are made of two tissues. We have the compact or cortical bone, which is basically the dense outer layer. It gives the strength and the protection. And we have the cancellous or spongy bone, which is porous inner layer that basically reduce the weight and contain the bone marrow. Now, as type of the bones, we have different types, starting with long bones. As you can see in the picture, they are long than wide, and they basically support, their main function is for the support and for the movement, like the femur and the humerus. We have also short bones. They are cube-like, they are spongy inside, and they help in the stability, like the carpals and the tarsals. We have the flat bones. They are thin and flat, and they help in the protection, like the skull, the ribs, the scapula. We also have something called the irregular bones. Basically, they have complex shapes, and they protect organs like the pelvis and the vertebra. And we have something called sesamoid bones. They are small and round in tendons. They protect the tendons like the patella, as you can see in this picture. And there is something called sutural bones. Can you see the pointer of the mouse?
Yes, ma'am.
Okay. So the sutural bones, they are tiny extra bones in the skull. Okay, they don't have like a major function. They are used for diagnostic clues if there's something wrong. Okay, so they don't have a major function, and they are between, like in here, these zigzag lines are the sutures. So is everything clear up till now? Okay.
Yes, ma'am.
Yes. Great. So I arrive at a scene, okay? And there's some remains that may be bones. First thing first, I should know if it's actually a bone or not. Is it a human or not? Can I see some signs of trauma or disease on the bones? And after that, I can do the biological profile. So how can I know if this is a bone or not? Well, you know, guys, not everything that looks like a bone is actually a bone. Sometimes it's wood, stone, or even plastic. So the first step for any forensic anthropologist is to confirm, is it a bone or not? We start by some kind of visual differences. For example, the color. Fresh human bones, they are yellowish to white because of the organic material and marrow. The old ones and the buried ones, they are some kind of brown or gray because of the soil and minerals. We can also check the texture, for example. The real bone is more porous. It's not glassy. Plastic or stone, they are hard and cold. We can check the shape. Of course, human bones, they have specific shapes. And we can check also the weight. All the human bones, they are light because the organic part is gone. The fresh ones, they are heavier because we still have the bone marrow and the moisture. However, stones and like artificial materials, they are unnaturally heavy or perfectly solid. And of course, we can confirm by doing some chemical tests. Like to be sure, scientists can test for calcium and phosphate, the main minerals in the bone. And this is done by like gently scraping a sample and checking its reaction. If calcium is present, it means this is a bone. If it's not, it could be plastic or mineral rock. We can also check for like the surrounding, if you found some kind of a cloth, a wallet, or anything that can give us an idea if it's a bone or not as well. Now, once we confirm it's a bone, the next question is it a human or animal? Because sometimes animal bones, especially pig, deer, and dog, look very familiar or similar to human ones. So we look for clues in shape, proportion, and in texture. And there are some things that we can look for starting with the shape and proportion. For example, like the posture for humans. Okay, they walk upright. But for animals, the legs are like, okay, so as I said, the posture for humans as the legs and the arms are proportionate because they walk upright, okay? For the animals, the legs are longer in the back because they walk on 4 legs. As for the pelvis, for a human, it's wide, okay? But for animals, it's long and narrow. Can you guys hear me?
Yes, ma'am.
Yes, ma'am.
Okay. So as I was saying, as for the pelvis, the humans, they have a pelvis that is wide, but for animals in here, it's long and narrow. And as for the long bones, basically in here, the long bones, in a human, they are straighter and more balanced, but in animals, they are more curved because they support in the running and the jumping. And then also I can check the skull. For humans, it's round and large, okay? But for animals, it's more elongated and more flat. Now, for the teeth of a human, they are small, okay, in here. And the jaw is more like a V shape. For animals, they have larger teeth and canines because they like tear the meat, and and they have a long jaw. We also have the difference between the limb bones. Humans have like longer legs than arms, and animals often the opposites. You can also check the vertebral column. Human spine has some kind of a S shape, okay, because it's an upright posture. Animal spines are more horizontal. And as we talked about the pelvic bone as well, for humans it's wide, for animals it's narrow. And the feet, humans have arched feet, animals have more like paws or hoofs. And as for the ribs, also humans have more circular rib cage, animals have elongated chest. Okay, so basically I just given you these just to know basically the difference. Of course, I'm not gonna deep dive into them. We can also check the texture, the bone texture, as we can see in this table, okay? So for a human, the thickness, it's more moderate and it's more spongy inside, but for animals, it's more dense. And for humans, the bone marrow is more red because it makes red and white blood cells. For animals, it's more yellow and fatty. We have muscly fat and that later can convert to red marrow. Is everything clear?
Yes, ma'am.
Do you have any question up till now?
Ma'am,
Yes. Okay. So now that I checked that the bones and turn out to be a human, some signs of trauma or disease can be shown. Okay. For example, if someone was shot in the head, I can see the round hole or the radiating cracks in the skull, like this one. Okay. So bones basically can tell us stories, not only about who the person was, but also about what happened to them. Injuries, diseases, and health problems, they all leave marks that last longer after death. And when I say trauma, I mean fracture, sharp cuts, gunshot. And keep in mind that we can also tell if these happened before death or at death. For example, let's take a gunshot mark, okay? We can see like a round hole. So what does this tell us? It tells us about the entrance and the exit wounds, which basically help us to reconstruct the events or to know what happened. If I take, for example, sharp cuts like this one, it's a straight, clean marks from maybe a knife. So what does this tell us? It maybe suggests that this person was stabbed, a cutting, or dismemberment. Okay, so as I said, it helps us reconstruct events. And we can also know if there were any diseases like infections, bone cancer, malnutrition by checking the texture, holes, and appearances. Honestly, I'm not gonna deep dive into them since we don't have a lot of time, but you can guys check for these. So I've put it some conditions for you that you can check. You can take like a screenshot or something and check them. And if you have any question, of course, do not hesitate to ask me. I will give you my email as well at the end of the session. So when we study, guys, the skeleton, we're not just looking at bones. We are reading some kind of a medical and personal history. Now I need you to like focus in the upcoming parts because now we will talk about the biological profile that we can get from bones. First thing first is the sex determination from the remains, or basically the gender, male or female. So when forensic anthropologists find skeletal remains, one of the first things we need to know is, was this person a male or a female? And we call this process the sex determination. It helps us actually to narrow down the identity of the individual right from the start. So we use two main types of traits. We have the non-metric, which is based on the appearance and the shape, what we can actually see. And we have the metric traits, which is based on measurement and size, what we can measure, which we will see in a bit. Now, starting with the non-metric traits. Non-metric traits, as I said, are about the look and the form of the bones, their curves, the angles, the roughness. So now, if I could only choose one bone to tell us whether the person was a male or a female, I choose the pelvis because it's the most accurate, giving around, I'm talking 95% certainty. And why is that? Because the pelvis is shaped by one main biological difference between male and female, which is childbirth. The female pelvis is adapted to allow a baby to pass through, so it's wider, rounder, and it's more open, while the male pelvis is narrower and taller. Let's break down now to the main differences. Let's see the overall shape. If you look at the pelvis from the top, okay? In females, it looks wider, more circular, okay? Like an oval. In male, it's narrow and heart-shaped, almost heart-shaped. And you can see this is the sacrum in here. The sacrum basically is the large triangular bone at the base of the spine, okay, that connects the two sides of the pelvis. So in males, it's longer and narrower, and it curves more into the pelvic cavity. As for in females, it's short and wider, and it's tilted backward because it enlarged the birth canal. You can also check in here. This is for females. This is for males. Also here. You can see the difference. Now we also have something called the pubic angle. This is the angle formed just below where the pubic bones meet, okay? In female, it's wide and open. It's like the letter U. In males, it's narrow and sharp, more like the letter V. Is everything clear, guys?
Yes, ma'am.
Okay.
Ma'am.
So you can also see in here for the pubic angle. For males, it's more like the letter V. For females, it's the letter U. It's more wide and open. We also have something called the subpubic concavity. Basically, they are near the lower front part of the pelvis. You can see in here. Look at this. This is for male, and this is for female. So in female, the bone is like curved gently inward, okay? It has this concave shape. In male, it's more straighter, okay? We have also something which is the ventral arc. This is a small ridge, okay, in here. You can see in here. This is a small ridge or curve on the front surface of the pubic bone. So basically, in females, it's clearly visible, okay? In males, it's absent. Check in here. This is for male, this is for female. So in female, it's present. In males, it's absent. And it's basically one of the best visual indicators because it's easy to spot when you hold the bone. Okay, because females, they have a noticeable arc that man or males don't. And we have something called the greater sciatic notch. If you flip the pelvis to the side, okay, there's a large notch between the ilium and the ischium, okay? What you should know is that the female, they have a wide and open one. The males, it's narrow and deep. I know it's not that easy because we are only like seeing them in slides, but if you can actually get your hand on some kind of bones, like in real life, you can obviously tell the difference. So I'm just, if there's anything that is not clear, please let me know so that I can explain it to you, okay? So now we finished the pelvis. I just want you to let me guys know which one do you think is for a male and which one is for a female. If you can open the mic, please.
A is for male and B is
Female.
Sorry, you said A is for?
A is
Ma'am,
for male, B is for female.
ma'am,
Okay. Can you tell me why?
Ma'am,
Can
A
you?
is for male.
Yes. Can you give me like how could you tell that A is for male and B is for female?
Ma'am, like you said, ma'am, if A structure is having a heart shape and B's bone structure is having a oval shape.
Okay, so B, it's more the basically it's more wide and open, and A is
And
more narrow. That's
yes,
right,
ma'am.
guys.
and ma'am, that pubic arc in A is greater than 90 degree and then in B is less than.
I mean,
That's
A
right.
is V shaped and in
Yes,
B is
true.
U shaped.
No,
That's
ma'am.
true, guys.
Ma'am, B is,
Yes.
I think, B is male and A is female.
Why do you think that?
Ma'am, because that in B, I think that pelvic inlet is heart shaped, and in A that is oval and round. Because ma'am, in A that is female, for childbirth that is oval and round, and the pubic arc, ma'am, is in this pubic arc is broader in A.
Okay, but like if you look in here, can you see the mouse?
Ma'am.
Okay. If you look in here for this pubic, how does it look like in here? It's the letter U, right?
Yes, ma'am. Yes, ma'am.
Yes,
And
ma'am.
this one is like the letter V. So
Yes,
basically,
ma'am.
one of the main differences that we have between male and female. So this is A is for male and B is for female. And B is also more wide and open because it helps for the birth canal. In here, it's more like narrow. Is it
Yes,
clear?
ma'am.
Is it clear, guys?
yes, ma'am.
Yes, ma'am.
Okay, great. Now, let's say I don't have a pelvis. So basically, the skull is our next best tool to determine the sex because the skull holds many clues. And male and female skulls differ in size, in shape, and roughness because of the muscle attachment and hormones. So if I'm taking about the general appearance, male skulls, they are usually larger, heavier, and they are more rugged. So the bone surface, it looks more rough because stronger neck and face muscles attached to it, and the features are very bold, and you can feel sharp edges and ridges when you touch them. However, the female skulls are smaller, smoother, and they are more delicate, if I may say. So the contours are rounder, and the bone surface is more soft, and the ridges, they are less pronounced than males. So now I want to talk about some cranial observations that we can check for the differences between them. And here are the indicators. I'm going to start with the nuptial crest. Basically, the natural crest, guys, is where the neck muscle attach, okay? It's right at the back of the skull, near the base. We're also gonna talk about the mastoid process, which is the small bone projection, right behind your ear. We're gonna talk about the supraorbital margin, which is the upper edge of the eye socket. We'll see also the glabella, and we're going to talk about the mental eminence or the mandible shape and difference. And we also have the zygomatic arc. So let's start with the natural crest. So as I said, the natural crest is where the neck muscles attach right at the back of the skull near the base. So in males, look at this. This area is rough and bumpy and more pronounced, okay? So it's forming a clear bump. And that's because men usually have stronger neck muscles. In females, it's more smoother and flatter, with maybe little or no ridge or bump visible at all. The next one is the mastoid process. So basically, as I said, the mastoid process, it's behind the ear. It's the small bone projection right behind your ears. So in males, the mastoid process is large and thick and project outward, okay? But in females, it's small, thin, and less obvious. You can see in here, this is for female and this is for male. It's projecting outward for the male. The next indicator is the supraorbital margin, okay? So basically, this is the sharp edge of bone just above the eyes, okay? In female, this edge is very thin and sharp and clear. In males, it's thick and round, and like you can see the difference from here, okay? It's more marked in males. In females, it's more sharp. Here, look at this, the supraorbital or the glabella. You can see in this, okay? The glabella, guys, is the smooth area between the eyebrows, okay? So in males, it's more pronounced and projected forward. You can see in here, it's projected forward. In females, it's flatter and smoother. And why is that? It's because of the testosterone, which influences the bone growth in the face and create this stronger ridges in males. Look at this. This is a male and this is a female. We also have, as our next indicator, the mental eminence and the mandible shape, which means the chin and the jaw, okay? So in males, okay, look at this. The chin is broad, it's square and more prominent, okay? In female, it's more pointed and more like rounded, okay? You can picture like Superman's jaw. Superman's jaw is strong and square. That's basically a typical male mandible. For the female, it's more like a heart shape. It's more round and narrow and smooth. The next indicator is the zygomatic arc. The zygomatic arc is basically the cheekbones, okay? So it extends from under the eyes to the side of the face. Basically, we cannot tell like in the pictures how it looks like, but in males, it's more thick and strong, okay? But in females, it's small and smooth. So to sum up everything, guys, if you find a skull and you want to estimate sex, a male skull is bigger, heavier, and more rough with a strong feature like a square chin, a heavy brow, large mastoid. A female skull is smaller, smoother, and more rounded with a delicate chin and less pronounced muscles. Why is that? Because males generally develop thicker bone areas because of the greater muscle use and the hormonal influence, while female maintain smoother contours due to the less bone reinforcement. So when we study a skull, we are looking at the story of the muscle strength and biology. So men tend to have bulkier features because of strong muscles and hormones that make the bones grow more rugged. Women have smoother, rounder, and skulls adapted for less strain, let's say, on facial muscles. So even without seeing the face, the bone themselves can tell us the difference. And it's very important to remember that not every skull will fit perfectly into the male or female category, because some females may show stronger or more masculine features, like, for example, having a larger mastoid process. And some males may have like more soft and more delicate traits. And that's because there are like natural range of variation among humans, and things like genetics, hormones, and muscle use can all influence how the bones develop. So when we look at a skull, we don't just check one feature and decide. As I showed you guys, 5 indicators or 6 indicators. We look at all of them together. The overall pattern tell us the most accurate result. Okay? Now, I need you guys to tell me, picture A, is it a male or a female, and why?
Picture A is a female.
Okay, why is that?
Mastoid process is smaller, chin is smoother,
Okay,
and the zygomatic bone is thinner.
okay, that's actually true. Good job. What about B?
It's a male skull.
Why is that?
My mandible is also like in square shape, and
Okay,
zygomatic bone is also more prominent in it.
okay. And what about the mastoid process in
Yes, my
here?
master process is present in it,
Okay, it's more outward.
more outward, more prominent in it.
Okay, good job, guys. Now, we talked, guys, about the non-metric traits, the one that we can see. Now let's check the metric traits, okay? The things that we can actually measure. And these rely on numbers and precise instrument to estimate whether the bones belong to a male or a female. So why we use basically metric traits? Because in many cases, we don't have the complete pelvis or skull. Okay, sometimes the bones are broken, burned, or we cannot rely on only shape to determine the sex. So measuring basically give us objective data, numbers we can compare to known average. So in simple words, it's like using a ruler instead of like guessing by the eye. It basically makes our result more scientific and consistent. Now, what do we use? Basically, forensic anthropologists use an osteometric board, this one. It's used for, it's a measuring device for long bones like the femur, the humerus, the spreading caliper to measure curved parts like the skull and clavicle. And we have the sliding caliper for smaller detailed measurements. And these measurements, they are compared with known male and female averages using some kind of formula. So we have a database, okay, and we run our results to this database, and we can like know to which gender this person is. It's, for example, if you go to a doctor, okay, and they tell you your height is 170 centimeter and your weight is, let's say, 65. So you compare these measurements to a known range to know if you are like overweight or on a good weight, or you should like get to a healthy weight or what. It's the same thing. We get the data from the bones and we compare them to already existing data to know to which category, if it's a male or a female, this remains belong to. Now, I can have some cranial measurements, clavicle measurements, sternum, etc. I'm going to talk about them, but very briefly. So basically, the skull is one of the most commonly measured bone because of the size and proportion. They vary between males and females. So the difference is that males generally, as I said, they have larger, longer, and more broader skulls. Females, they have more smaller and rounder skulls with short facial height. The clavicle, this is the clavicle, guys. It helps us estimate sex because its length and thickness vary, okay? Male clavicle are more longer and thicker and more curved because they have like these broad shoulders. Female clavicles, they are shorter and thinner, and they're more delicate. And we can also see the sternum. It sits in the center of the chest, and its proportion also can help us determine the sex. So male have more longer and heavier. Females, they have shorter sternum. It's like you are comparing two thighs, you know, guys, like the male sternum is the longer thigh and the females is the shorter one. We can also measure the humeral head and the femoral head and other long bones. How is that? The humerus, which is basically here is the humerus, it's our upper arm bone. It tells us a lot about the body build and sex, okay? So the difference is that male, they have like, this is the humeral head, okay? Male, they have larger and thicker humeral head because of the greater muscle attachment, while females, they have smaller and smoother ones. Same goes for the femoral head. The femur, which is one of the most also reliable for measuring sex, this is the femur, okay? So for males, they have in here the femoral head, larger and thicker femoral head, and females smaller and lighter. And we can also use other long bones. If we don't have the femur and the humerus, we can still use these like the tibia, the radius, or the ulna. Basically, it's the same. For males, they have longer, thicker, denser bones, and for females, they have shorter and more delicate and thinner bones. Okay? And also, you should guys remember that there are some natural variations. Some females may have larger bone measurement, and some males may have smaller ones. So we never rely on only one single measurement. We look at several bones together and we check if the pattern fits male or female averages. So measurements are basically a guide. They don't tell us like 100% by themselves. We combine them with the visual traits, which make our estimation very strong. Now, our results are accurate. Well, it actually depends on which bone we are working with. For example, if I'm using a pelvis, it's 95% accurate, but let's keep in mind that sometimes it can be incomplete and maybe not present. So we will have to work with other bones. So if we have the skull or the sternum or any long bone, we can work with that. So, and you should know that the more the bones are incomplete, the more the accuracy decrease. Okay, so we should have more complete bones to let our accuracy increases. And as for the children, we can still determine the sex, but it's kind of hard, especially that they still lack this sexual dimorphism. Do you guys have any question before we go through the age determination? Is everything clear?
Yes, ma'am.
Okay. So now that we determined the sex and we know our remaining belongs to a male or a female, we can still detect or estimate the age of the person deceased. And we usually do that by referring to certain bones and to the teeth, since they actually change as we grow. So we are going to have like two categories. We will see the ones related to sub-adults, or basically the people under 18, and the ones for adults. And keep in mind that we can never give an exact age. We only give an age range. And this is because people, They grow at slightly different speeds, but the bones still give us clear clues. And also, before we deep dive in the details, I just want to show you first the human skull and give you a brief about it, since we are going to use the skull to estimate age. So basically, the human skull, it's the foundation of our head and it protects our brain. What is the cranium? The cranium is basically the big rounded part of the skull that protects the brain, okay? It is made of 8 bones, as you can see here. We have the frontal, parietal, occipital, temporal, sphenoid, and ethmoid. We have 2 parietal and 2 temporal, okay? And these bones are joined by sutures. These are the sutures, the zigzag lines, okay? And they act like, you can say like some kind of stitches. So you can like imagine like the skull, it's like a puzzle made of 8 pieces, and the sutures are like the lines where the pieces meet. And these sutures, they start to open in babies, okay, then slowly close as we grow, which is why they are useful for age estimation. So let's get to know more about how we determine age, starting with the sub-adults or the one under 18. One second, guys. Okay, so for children and teenagers, age estimation is actually very much easier because their bones and teeth grow in a very predictable stage. So we use the 3 main indicators. We have the dentition, which is the most reliable method. Teeth basically are the best indicator of age in children because they always grow in the same order at the same time, even before birth. And why is that reliable? Because we have, for example, baby teeth and adult teeth, they start to show or erupt at specific ages. And the root formation is not like affected by nutrition and health. And teeth give us very accurate results, especially from birth to teenage years. So now we have in front of us, this is the chart, okay? The Atlas of a Human Tooth Development. This chart shows how human teeth form and appear or erupt from before birth until early adulthood. So it actually helps forensic anthropologists estimate a person's age based on which teeth are developing or visible. So in here, this chart is arranged from the top bottom in here as you go down to there, okay? Each row represents a different age, and we have the upper and the lower jaw. So let's start with before birth, and I'm talking in here till here, okay? Teeth start to form inside the gum, okay? But we don't have any teeth erupted yet or shown inside the jawbone. What does this mean? This means that the baby is still in utero or it's a newborn. Now, if we go from birth till here, 2.5 years, the baby teeth start to erupt. The first teeth start to appear around the 6th month in here, if I may say in here, okay? And by 2 and 3 years, all the 20 baby teeth are visible. Then we have from 3 years till 6 years, till here, baby teeth, they are fully appeared, okay? Permanent teeth are forming. So basically, if we see this, we can tell that, okay, this is a child between the age of 3 and 6. We also have something called the mixed dentition, which is between 6 and 12 years in here. And by mixed, I mean both baby and adult teeth are present. And by 12 years, okay, most permanent teeth are in place except of the wisdom teeth. And then we have from 13 till 21, all the permanent teeth are erupted or developed. So in short, I know because this chart can be a lot. I have made this table for you guys. You can see from before birth what tooth or teeth are present and the approximate age of which. You can take a screenshot of it if you want. Do you have any question up till now? All is clear, guys?
Yes, ma'am. Everything clear.
Okay. So I need you to take a good look at this because we are having a small activity right now. Okay. Our first question. If we see only baby teeth, does that mean that the child is under 6, is 6 to 12 years old, or is an adult?
Under 6. Under 6.
Good job.
Child under 6.
Good job, guys. The second question. If we see a mix of baby and adult teeth, does that mean that the child is under 3 years, is adult, or 6 to 12?
6 to 12.
6 to 12.
6 to 12.
6 to 12.
6 to
Great.
12.
Great. Now, the third question is, if wisdom teeth are forming, that means late teenager, 6 to 12, or child under 6.
Late
Late
teenager.
teenager.
Late
Late
teenager.
Good job.
Late teenager.
Good job, guys. Okay. So now we're gonna go and see the cranial suture fusion. Okay, it's also one of the first things we look at is how the skull bones fuse together as the child grows. Okay, so baby don't have a fully solid skull. Instead, the skull has these soft areas. They are called fontanelles. Okay, so fontanelles are the soft spot on baby's head, and these exist because the skull bones haven't fused yet, and this allows the baby head to be more flexible during childbirth and give like space for the brain to grow. Now, if we look at the anterior fontanelle in here, okay, this is the famous spot everyone talks about. It closes around 18 months. We have the posterior fontanelle. It closes very early, around 1.5 or 2 months. We have the anterolateral or the sphenoidal. It closes at 4 to 6 months. And we have the posterolateral. It closes around 3 to 5 months. Why does this help us estimate age? Because each fontanelle closes at a very specific age range. Okay, so if we find a skull with one of these still open, we can immediately know the child approximate age. And you can see in here this table that I've put for you. Also the role of each fontanelle, if you would like to know more about it. Okay. Take a good look at it because we are gonna have a small activity also. So basically, like the pattern of which soft spot is open or closed tell us the child's age range. And these are basically some of the easiest and most reliable clues for like estimating age in babies. So our first question, if the anterior fontanelle is still open, that means the child is more than 18 months, less than 18 months, more than 2 months.
Less than 18 months. More than 2 months. More than 2 months.
I'm just checking the comments. So you said it's more than 18 months? Let's take a look at this table. the anterior fontanelle is still open. This one. So the baby is
Less than 18 months.
great. So the child is less than 18 months. Now the second question is, if all fontanelles are closed, that means the child is older than 5 years, older than 18 months, older than 2 years.
Older than 18 months.
Older than 18 months.
Look at this, you guys. Basically, B and C are both, because 18 months, it's like the anterior is the last one to close, right? So basically, the child is older than 18 months. You guys are right. Okay, now let's go to... Do you guys need a break, like 2 minutes? Guys, can you hear me?
Yes, ma'am.
Let's have a 2 minutes break, okay? Because I
Okay,
want
ma'am.
to drink. I just want to drink water, honestly.
Okay, ma'am.
Okay, ma'am.
சொல்லிட்டுதான் வந்தேன் அவங்கள்ட்ட
Okay, guys. Are you ready?
Ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. So now let's talk about our third indicator for the under 18 years old, how to determine or estimate the age. We have something called the epiphyseal union. Basically, it's the end of the long bone, like long bones like the femur, tibia, humerus, and clavicle, okay? So these ends, they are called the epiphyses. So in kids and teenagers, the epiphysis is separated from the main shaft. And as they get older, these parts start to fuse together. So we have like fusion stages. If it's open, it's more like a child or a young teen. If we have a partial union, it's more like a mid to late teens. And if it's complete, we're talking about early adult between 18 to 22. So we use the femur, the tibia, the humerus, and all of that. You can see in here in this picture, the picture number A, okay, the shaft and the epiphysis or the end of the long bone is separated, which means we're in the first phase, it's open. The fusion, it's open. The second one, they are united, but they are partially united, okay? And the C, we have a complete fusion or union, which means that this one belongs to an early adult, this one to a mid to late teen, and this one to a child. Now, we also have the... Okay, so now we're done with the subadults. Once someone reaches adulthood, the bones stop growing. Okay, so instead of looking at the growth, we look at how the bones age over time. So the best adult age indicator comes from like 3 areas. Okay, we have the pelvis, the rib ends, and the clavicle. So we're gonna start first with the pelvis or the pubic symphysis. It's the most used adult method. Okay, it's in here. It's the joint in the front of the pelvis where the 2 pubic bones meet. Okay, and this surface changes its texture as we age. And I'm gonna show you in here. You can tell the difference. Look at the young adult. It has deep ridges and grooves, and it's bumpy. For the mid-age, okay, it's more like smooth and more oval, okay? And for as we get older, you can see these irregular, porous, and eroded. Check in here, from 18 years to 102. More bumpy and ridges, become smoother over time, and more porous. We also have something called the auricular surface, which is on the hip bone where it connects the sacrum in here. And it looks like an ear, that's why it's called auricular, okay? Same thing, look in here. As it is young, it's ridged, it's more tight. Mid-age, it becomes, the ridges start to like fade a little, and it becoming more like grainy. And as we get old, it's more flat and porous and irregular. You can see the difference in here. It's from 18 years to 102. The ridges are more shown, are more visible. In here, it's almost like flat, and it's more porous and irregular. We also have the sternal end of the 4th rib, which is basically in here. Okay, it's the rib ends, they slowly from smoother to hollow as we age. Okay, and also look at this. In here, it's more flat and it's slightly curved and it's more smooth. Mid-age, let's take 46, for example. Okay, shallow and thin rim. In here, look at 85. We have these sharp edges. And this picture as well, this belongs for a 19 years old. This belongs for a 60 years of age. So you can tell the difference from the edge. It was more smooth. Okay. We also have the iliac crest and the medial end of clavicle. So the iliac crest in here, it's the top edge of the hip bone. Okay. The medial clavicle, it's the inner end of the collarbone near the chest. And these are some of the last bones to fuse in the human body. That's why we kind of use them. If there's no union, it means it's a teenager. If there's a partial union, it means late teens. If it's complete union, we're talking about young adults, yani between 21 and 25 years. Now let's take this image. What are we looking at? So these pictures show the medial end of clavicle from different individuals. So this part of the clavicle is basically one of the last bones in the body to finish the fusion. So in the left image in here, you can see that the bone ends look rough and uneven. Okay. Some still have this separate small pieces that hasn't fused. And the edges, they are more like irregular and incomplete. This means that this person was still growing. It's probably a teenager, a very young adult, maybe under 20 or 23 years. In the right image in here, the bone ends appear more rounder and smoother. And there is like no visible gap. You cannot see the separation. So basically the epiphysis is now fully attached to the bone. It looks like a compact and mature bone, okay? So this means that the person had completed skeletal growth. It's in their early to mid-20s or maybe older. Why is this important? As I said, the medial clavicle is one of the last bones to fuse, even later than the iliac crest, which we will see in a bit. Because of that, it's a key indicator for estimating age in young adults. So if the clavicle is still unfused, the person is still growing. If it's partially fused, they were in their late teens or early 20s. If it's fully fused, they had reached adulthood. Okay? The second picture shows the iliac crest. The left one, okay, you can see clearly the separate edge in here. It's separated, okay? And the thin plate of bones of top, okay? There is a visible gap or line between these two parts, which means that this person is likely a teenager. The fusion is not completed. However, look at this in here. It's totally fused, okay? The surface is more smoother and continuous, and there is no separation line, which means that the person had finished skeletal growth. So the iliac crest fuses late in adolescence in around like 17 to 23 years, which make it very useful indicator for young adult age. If it's still separated, it's a sign of teenager. If it's partially attached, the person was near adulthood. If it's fully fused, it means a skeletal maturity or the person had like reached adulthood. Okay, is everything clear, guys? So I just want you to know, guys, that when we estimate age, we read the growth story written in the bones, okay? In children, like we see rapid changes, new teeth erupting, bone end fusing, skull sutures closing, as we saw. In adults, we see like slow aging, you know, surface becomes more smooth, joints like wear down, ribs become more hollow, we see some kind of edges. So together, these clues help us place the individual into an accurate age range. Again, we cannot tell the exact age as it is. So now we're gonna go and see and talk about the stature estimation. So we identified the sex and the age. The next part is the stature, meaning how tall the person was when they were alive. Stature means height, okay? Bones, especially long bones, grow in a length as we grow taller. So by measuring certain bones, we can estimate the person's height. Now, which bones do we measure? We mainly focus on long bones because they are the most strongly related to height, like the femur one, tibia, humerus. We can, if these bones are missing, we can lay on a radius, ulna, and fibula. Now, how do we measure these bones? Okay, we have this osteometric board. We just talked about it a few moments before. It's a long and flat measuring board. It's used to measure the maximum length of a long bone. So the bone basically is placed between these two fixed ends, just like we are measuring, let's say, a plank of wood, and it gives us an accurate measurement in millimeters. We have also something just like this. We have also something called sliding or spreading calipers. It's used for smaller bones or when the bones are like more curved. It's very precise for like taking diameters or head measurement. And it can be used when only fragments are available, like small parts. So after measuring and everything, we use some kind of scientific formulas developed from studying like thousands of known skeletons. And these formulas depend on the bone measured, is it the femur, tibia, humerus, the sex of the individual, the ancestry. And based on that, we can know the height or the stature of the person. Now, what if some bones are broken or missing? Even if the bones are incomplete, we can still estimate the missing part and calculate the height, because a partial femur or humerus still give us useful data. The more bones present, the more accurate the final height will be. So when we have multiple long bones, we compare all the results and we use the average range. So guys, basically stature estimation is simple. Okay, we measure one or more long bones using like osteometric board or calipers. We plug those numbers that we get into a well-established formulas, and we get a very good estimate of how tall the person was in life. Is everything clear up till now?
Yes, ma'am.
Okay. Now, let's talk about ancestry determination in forensic anthropology. First thing first, before we start, it's very important to understand a key difference, guys, between race and ancestry, because they are not basically the same thing. Race is more like a social concept, like it's based on appearance, skin color, hair type. It's not scientific, and it like changes across the cultures and history, and we cannot actually determine it using bones. However, ancestry is more a biological concept. It's based on like inherited skeletal features. It can be studied scientifically and can actually be determined from bones using measurements and like visual or non-metric traits. So you should know that ancestry is biological, race is social. And bones do not show race, they show ancestry patterns. Now, what is ancestry determination? When we talk about ancestry in forensic anthropology, we mean identifying like the broad biological population group an individual belongs to based on some kind of skeletal traits. So we commonly like use the three large population clusters. We have the Caucasoid, which is the European. We have the Mongoloid, the Asian, and Negroid, which is African origin. Okay, and these are not races; they are biological patterns groups used to help identify unknown human remains. Now, how do we determine ancestry from the skull? Bones, especially the skull, they have small but like consistent differences across the population. So we have like two methods, okay? We have the visual ones, which is morphoscopic traits. We look at the shape of the skull and the face. And we have the morphometric, which is the measurement, like we use calipers and formulas to measure specific distances and angles. And both of these like two methods, the morphoscopic and the morphometric, they help anthropologists to like estimate the ancestry. Now, let's deep dive into the key skull features for ancestry determination, starting with the cranial vault. You can see that for the European, the cranium, I'm talking about the cranium, okay? It's high and narrow. For the African, it's long and low, if I may say. And for Asian, it's more rounded and wide in here. Okay? It's more round, it's more low, and it's more high and narrow. Same goes, it's from females, same goes for males as well. Now, what about the nasal aperture? For European, it's more like we have a narrow and tall nose opening, okay? The nasal bridge is more like sharp and pronounced. For the Asian, they are medium, it's more rounded, okay? And for African, it's wide and rounded. It might be not that easy to tell the difference, but like when you see it in real life, you would be able to do that by looking at the nasal aperture. Now going for the eye orbits, if you see it in here, you wouldn't be able to tell the difference, but look at this picture, at the same picture of the nasal aperture, okay? For the European, it's more angular, okay? For the African, it's more like rectangular, and for the Asian, it's more like rounds. It's not really shown in this picture. In here, it's more round, it's more rectangular, and in here, it's more like angular. We also have the zygomatic arc. In European, it's less pronounced. In African, it's pronounced, but like moderately. And in Asian, it's very pronounced. And it's more like it's projecting outwards. That's the main like difference. If I know like we cannot see them very clearly in the pictures. I'm sorry guys, but like if one time you would able to like see them in real life, you would obviously be able to tell the difference more. Now let's talk about the palate shape and the teeth and jaw. So basically for the palate, you can see in here the African, they have like a U-shaped one, okay? The European is almost like a V. It's not a V, but it's almost like a V. And the Asian, it's more like a round. In here, like almost a rectangular U shape. Here, almost like a V. In here, for the Asian, it's almost like round. And as for the teeth, the European, they have like small jaws and they have like narrow teeth. The African, they have larger jaws and they have these small gaps between the upper front teeth, okay? And for Asian, it's like a shovel shaped, like for example, the front teeth, they are curved like a shovel, okay? It's a strong distinctive marker. You can also tell it when you see it in real life. And also if you wanna like talk about the chin and the mandible, look at this. The African, in here, the negroid, the African, it's more broad. The European, it's narrow, and the Asian is like intermediate. Okay. And I also have put it into a table for you because I know that it's not that easy to like get it from the first time. So you have this table that you can like rely on to check it. If one time like you really had your hands into a real ones, like for you to see the difference, you can use this table as well. Okay. So how do anthropologists actually confirm ancestry? As I said, they use morphoscopic traits, which is visual comparison. We saw these. And we also use metric measurements. We use calipers, okay? And they use like some kind of statistical softwares and 3D scanning, okay? It works just like comparing fingerprints, guys. Like we look at the set of traits that we have and the pattern tell us the most likely ancestry, okay? So to sum up the ancestry, you should know that race is social, it's about appearance. Ancestry is the biological part, it's about the bones. Forensic anthropologists, they estimate ancestry, they do not estimate race at all. We look at the skull shape, nose opening, eye orbits, jaw, cheekbones, teeth, and these traits help narrow down the population group to the person that we found belonged to. So ancestry determination is like one more piece of the puzzle. It helps us to like understand where the person likely came from, so we can like better be able to identify them. Do you have any question, guys? We are almost done. So right now I'm gonna give you some little information, and we're gonna talk about 3 cases. So do you have question up till now?
No, ma'am.
Okay. So it's very important for you guys to know that bones, they are not collected like randomly, okay? So just like any scene, any crime scene, the scene is secured and documented first. Like we take photographs overall, mid-range, close-ups, and we take notes on the position, the orientation, if there's any clothing, objects, we do the mapping, we do the sketching and everything. And the bones are collected physically. How? They are picked with clean gloves, of course. We can use soft brushes to remove the soil, the loose soil. We do not wash bones at the scene. And they are, of course, packaged and collected carefully to avoid any contamination. For example, it's like preferred to use paper bags or paper envelopes because they allow the airflow, and they prevent the moisture to build up, and they like reduce the DNA degradation. Okay, so each bone should be like packaged separately, especially if the bones are like from different body regions. Okay, and if we have like trauma analysis is needed as well. We usually avoid plastic bags unless it's like temporarily, like because plastic traps the moisture and it leads to like DNA degradation and the mold. It's only acceptable for a short term, for example, if the bones are very wet. Now, I would like to give you some case studies. But let me just tell you that I couldn't really found some real studies with names of people on the internet or websites, because I think it's more of a classified information, like we do not actually share a lot of it, but I could have found some unknown cases. Okay, so in these cases, you're gonna see that forensic anthropologists used the bones that they found in order to be able to determine the sex, the age, the ancestry, and also the stature. So you would see how important forensic anthropologist's job is. So the first case, I gave you also the source for you to be able to like look it into. So they found skeletal remains in a forest area, and it's very decomposed, and they only had that bone remains. So they examined the pelvis, the skull, and long bones like femur and tibia, and the sternal end of the fourth rib in here. So you can see the ribs, the femur, tibia, the pelvis, and the skull. So they determined the sex. How did they do that? Because they saw the pelvis having a narrow sciatic notch and a narrow pubic angle. You remember, guys, we talked about the pubic angle being like the letter V. It's narrow. And also they saw some features on the skull, like it has large mastoid process and more pronounced brow ridge. So they knew that this person or these remains belong to a male. As for the age, they looked for the pubic symphysis, and they also saw the rib end. You guys remember the rib end? This one. Let me show it to you. This one. This is the rib end. They were able to tell from this rib end the age, which is basically was 35, if I'm not mistaken. Yeah, 30 to 35. As I said, they cannot give the exact age, but only the range. And as for the stature, they used the femur, which is the long bone, and measure it with the osteometric board, and of course use some kind of formulas that they have, and get to know the approximate stature of the person deceased. And as for the ancestry, they looked at the skull. They saw medium nasal aperture and rounded orbits and the mandible shape. Of course, they compared these traits that they found to the existing data of they already have for people and different ancestries, and they knew that it belongs to a South Asian person. The second case is for an unknown female. They discovered the bones from an agricultural field after animals had disturbed the soil. Basically, they examined the pelvis, the clavicle, the mandible, and the teeth. These are the ones that they examined. So they determined the sex to be a female. How is that? They looked at the pubic bone in here, and they saw that it is wide, even though it wasn't complete. Let's say it wasn't complete. It's you can still tell from some kind of features, because we have a lot of features in the pelvis that we can use to determine the sex. So they looked at the pubic angle. It's wide. It's more like the letter U. They looked at the skull and they saw small mastoid, smooth brow ridges. So basically, it belongs to a female. They also compared it to the data that they have. As for the age, they looked at the medial end of the clavicle also, and they saw that it was partially fused. You remember, guys, we have 3 stages. We have the if it's not fused, if it's partially fused, and if it's fully fused. So if it's partially fused, basically we're talking about middle age. And they also looked to the teeth. So they knew that it belongs to a person between the age 20 and 25. As for the stature, they used the humerus. And in here, I put for you the formula they used for Indian females. So they got the measurements and everything, and they applied this formula, and they get the estimated stature, which was between 155 and 158 centimeter. As for the ancestry, they looked to the dental arc shape, the palate, and the nasal morphology. Also examined them very carefully, took measures, and compared them to the data they have, and they came out to the conclusion of that this female was coming down from a South Asian ancestry. The final case that we have in here, it's for a child. They found the skeletal remains in urban garbage. Okay, they examined the skull, they examined the teeth, and the long bones. Guys, I just want to ask you a question. You already know that as for the title, it's unknown child between 1 to 2 years old. Do you think that they were able to determine the sex of this child or not?
No.
Why is that?
Because of the immature sex deformation.
That's really good. Good job. So they couldn't tell the sex because he lacks of this sexual dimorphism yet. He's 1 to 2 years old. So what do they determine? They determine the age. So they looked at the, let's say, the skull, okay? The anterior fontanelle is still open, and the posterior fontanelle is closed. And they looked at the teeth. They are consistent within 1 to 2 years. So that's the only thing that they could have determined, honestly, only the age. They couldn't determine anything else because it's still very young and there's no like features that can tell us more about the sex or anything else. And that was all, guys. Do you have any question? Is everything clear? I'm gonna write for you my email in the comment section. If you have any question, you can always contact me. Is everything clear, guys? Yes, hold on a second. I will give it to you. I'll just give you my LinkedIn profile. 1 second. So guys, if you have like any question, if you'd like to ask about anything related to forensics, anthropology, or anything else, I would be so happy to help and to answer all of your questions via email, of course. It was a pleasure to uh, give this session, and I really hope that you guys like learned something new from me, and it was everything clear. And I'm looking forward to like seeing you guys thriving in this field because it's really an amazing field. And yeah, basically that's it. And of course, you're gonna have an assignment that Mr. Swapnil is gonna, uh, I think, give it to you.
Thank you so much, ma'am. So, before we conclude the session, I would like to inform everyone about the assignment.
Yeah.
So, guys, we have one Google Forms as an assignment. So, you would have 20 questions which you need to answer. Okay. So, I would provide the questions to you after the meeting ends. Fine. Do you have any other questions?
No, sir.
Okay, great.
No, sir.
Great. So thank you
Thank
so much,
you.
ma'am. It was
Thank
a very insightful session, and
Thank you
I
so much.
really loved the way you gave them the chance to interact with you and to solve the activities. Forensic anthropology is often seen as a daunting subject, but the way you connected the biological aspects of the skeletal analysis with your real world experience in criminal investigation and the evidence collection, it made it truly accessible. We are especially grateful for the practical examples that you shared, which highlighted how anthropology fits into the larger puzzle of solving a crime. Your diverse background, spanning everything from fingerprints to forensic psychology, really shines through your holistic approach in teaching. Thank you so
Thank
much for
you
your
so much.
continued collaboration with Forensic Fusion and for joining us today, all the way from Lebanon, to mentor our interns today.
Thank
Thank
you
you
so
so much
much.
once
My
again.
pleasure. It's my pleasure. I'm sorry, I really wanted to get to know everyone, but we don't really have a lot of time. So thank you so much for having me. And I hope that we will be able to do more of these insightful sessions in the future. And of
Most
course,
definitely.
if any of the students or the attendees have any like ideas about future sessions that they would like to know more about, more topic, we would be open to that, of course.
Sure. So everyone is requested to please follow ma'am on LinkedIn. I would also share it in the WhatsApp group, ma'am's LinkedIn account, as well as her email ID, so that if you have any doubts, any suggestions related to the future sessions, please feel free to reach out. Thank you so much once again, everyone. Have a great evening ahead.
Bye bye.